Hi, welcome to this video. Interesting quality lab techniques is kind of following along with Goodwin University's BMM 229. And this is our first lab of the module. We're looking here at a dial gauge. This is a digital dial gauge. We're going to measure that part that I just showed. So the dial gauge does not measure obviously more than about a ½ inch. So we're going to start by using some gauge blocks to set an initial height and to zero out the dial gauge. So I'm going to lower this whole mechanism down on the stand here and get it kind of close. Ultimately what I'm going to do is tighten the top knurled nut. And once I get this sort of set for height, and now there's an adjustment here where I can lower this down, and I'm going to drop it down on the gauge block a bit. I'm going to drop it down a bit so that when I tighten the main mounting nut onto the stand, it will bring it to zero. Now look, I'm tightening. There, I've got it just to zero, and I can pull this 1-inch gauge block out. And that's my starting point now. Now I'm going to set it on the part, and you see it says 0.3745 inches. So if I add that to my 1-inch gauge block, which I'm trying to show you the one on here, the lighting's not allowing it, we have a height of 1.3745. Okay, pretty simple. This part here, you think, well, maybe we can just set this down onto the surface plate and zero it, and then go up onto that part. Perhaps it is within that range. I'm just going to zero it out here, and we're going to lift it up and see if we can stick the part in. Nope, seems to be a little taller than that, so we're going to have to raise it up, and we're going to find a gauge block that is approximately the size of this part's height, but generally speaking you want it a little shorter. So that one's a little tall. Let's grab another one. We'll go with 0.6 inches, or 600 thousandths as it's known. And that seems to be shorter than the height of that part. So here I'm trying to show you 600. And we're going to, once again, we're going to bring this down, locking the top knurl nut, and then bring the adjustment down to drop it in on the part. And I'm tightening it up on the shaft here, and you can see how that sort of takes up the slack. And oh gee, guess what, I failed to zero the dial gauge properly first, so that's why I'm not achieving that. So I'm going to relax this back out again, plot my part, zero it, bring my part back in. Should always lift up on the top there. And we're going to tighten this back up on the shaft until I just get to zero. I don't worry about that little 5/100 thousandths indicator on the side there. And we have 0.1244 inches added to the 600 thousandths we have there. So those two together, 0.725 roughly. Alright, we're going to move right along now. Here we're showing the Keyence digital microscope. It is warming up right now. It's got the sort of the kit car warm-up thing going on. Here we are. We're going to look at this broken off end of a key. I'm going to set this up on the platform here. And now you can see over below the stage here, there's this knob that's we're going to use to raise the platform up. And this is the way you should start. You should get to a point where you're almost in focus here. And there's a little joystick on this thing here, so I can drive it around until I've got it relatively into view. And then on the side here, I'm using the coarse focus control to try to bring this thing relatively into focus. You notice on the screen there's a little pop-up window there that has a green stuff in it. And that, as I kind of come past center focus and then go back, it creates a little bit of a peak on there. And so if we come back to center of that peak, we're in optimal focus for this particular key-shaped end here. Okay, so let's look at a couple of things here. We have over here in this menu an icon for lighting, and we can light it a few different ways. We can use direct lighting, and we can adjust the intensity here on this little remote piece. And you can really see how the metal was rolled out with that. It doesn't really highlight everything great. We're going to add a partial direct light here. This is the ring light we were using before, and that lights it pretty well. It's partial ring light, and I'm going around flipping all the different lighting segments on that. And then we could do a mix of the two. So that highlights the metal and gives you a pretty good overall view. But for the sake of this exercise, we're going to use the ring light and just adjust our light intensity so we can see it nicely. Okay, now we're going to go and we're going to look at the measurement tools here, and we're going to use plane measurement here. And I'm going to pick what will be the measurement of a line. So this will measure between 2 points. And basically we're going to use the mouse to place hits onto this graphic model on the screen here. And I'm just going to put an X at either end of this. And then the tag with the actual measurement will come out. I'm sorry it's a little hard to read here, but that will show your measurement currently in millimeters. Same thing I'm doing here. Put one X at one end, put one X at the other, and then drop my tag. And if I wanted to, I could take a photo of this fully annotated image by hitting the record button on the remote. Down at the bottom there, I was showing a selector for millimeters, meters, or micrometers. Most of the time in microscopy we use micrometers. Here we have it set for millimeters. Okay, I'm doing a diameter now, so I place an X on one side of that circle, one on the other side, and then I'm dragging out the circle and fitting it as best I can, then pulling the tag out to the side. It's the diameter of that circle. It doesn't need to be a complete circle either. Lastly, we're going to look at how to do an angle here. I'm going to use angle 2, and what it does is allow us to place a marker and create a line up the side of the end of this key here. When I get it placed pretty well, I will then move over to the other side of the angle, place an X and another one up that. And now I've got to decide, do I want the angle on the bottom, on the top, or on the side? No, the bottom and the top are the same, so we're going to pull that up, and the angle is listed right there. All right. If you press delete all over on the right side here, we'll get rid of all the annotation on this. We'll just say yes here, and it's gone. You can delete them one by one, or you can delete the whole bunch of them. So that's the basics of that. Let's just take this thing out of focus here and show you a quick way to do this. There's a full automatic version of focus here. You saw how quick that was. Bam. Or, if that doesn't suit you, it says right there on the screen you can double click on the image and it will pull it into full focus for you. So here we're just double clicking right there, and bam, there we have it. Fully in focus. So a couple different ways you can do it. Alright, we're moving along now to a electronic height gauge. This is the Trimos Vectra Touch. This is a not fully automated, but fully electronic control. I'm turning it on here. It takes a second or two for the brain to warm up. And it says Trimos. I'll tell you a quick trick. If it doesn't come right on, there's a little hole in the back where you can put a little needle or paper clip in, and that will sort of clear the problem. Right now it's going through the reference phase, so it touches the table, comes up, and now it's coming down and waiting for this reference standard to come over, which is this cylindrical object over on the left side here. The little slot on it represents what you see on screen. Be sure not to drag it on the table, but to place it into position. Then press the Enter button on the keypad, and it will move between the two extremes on that standard twice. And when it's done, it will show you the probe, and we're ready to measure things. So at this point, we can take the standard out of there. There's a little paddle control over here that I'm using. You push up or down, it makes the probe go up or down. It sort of has two positions, slow and fast. You could see right now the display says we're at -4 inches or something like that. We want to zero this thing out from the table height. So I'm slowly bringing it down. It makes a beep sound. And we're going to press the number 6 button, which says 0. And now you can see our display is fully zeroed out. Alright, so I'm going to raise the probe up. And you can see it'll move really fast if you're not careful with that trigger, and you really don't want to smack it down into the table. So the slower position works really nicely here for moving the probe up and down. There's also this button on the handle here that says air. It shoots jets of air out the bottom and makes it move like an air hockey table. Okay, I'm bringing the part up. I'm setting it on the table. I'm not dragging it around on the surface plate. And then I'm going to raise my probe up, make a height measurement on one of these little tabs, use the air button to move the probe to the article so that just the ball tip, the ruby ball, is exposed when it comes down and makes contact. And you heard that little beep there. That means it took a measurement. And it shows it on the display. It has a line item for each measurement that you make. I'm going to move it down, make a measurement of height on another one of these fins, move it over using the air, square it up, put it just one little click down, and it will automatically go beep when it comes to contact, and there's your height reading, and then move it away. Don't move your article around, move the Trimos Vectra Touch. Alright, we have this function button here, and it's going to change it from standing height to diameter. I'm going to zoom out and show you another way to do this here. On the handle there's those two little buttons, a yellow one and a blue one. The blue one is just like the function button. If I press in and out on that, that's going to change the function from standing height to diameter. If I zoom out here, you can see the display change when I press that little button. Alright, so let me come over. There you see, diameter, standing height. Same thing with the function button. Same exact thing. It depends on how you want to do it. So we're going to do a diameter here of this big hole, and then we're going to do that raised boss hole above it, though you won't see me doing that portion. So let me bring it over, set it down, use the air button to move this thing into position, and drop the probe down onto that lower surface. So at the moment I have the standing height selected, so it's just telling you the bottom height of that. I'm going to switch it to diameter, drop it down to the bottom of that circle. And now you see there's little arrows at the bottom of the screen, and what I'm trying to do is move this back and forth around the bottom of that diameter to try to find the lowest point. There's two little arrows that will almost line up. You want to get them as close as you can, and then switch and go up to the top. And the graphic shows you the probe at the top of the circle now. So it comes into contact, makes a beep sound, goes back to the arrows. Again, I'm trying to line those arrows up as best I can to show the very peak of that. So now on the display we have two things there. We have a line item that says dia for diameter, and then another line just below it which says cen for centroid. So the diameter is the diameter of that circle, and it might be worth trying that a few times and getting an average of those numbers. The centroid is the standing height of the center of that circle. Alright, I'm going to move this now. I'm not showing you the article, but I'm showing you the display portion here. I'm moving up to the raised boss circle above it, which is kind of what they're showing there in the graphic, since they use this very part in their display. And once again, we're going to measure the bottom of that circle, and I'm going to move it back and forth using the air button until I get those arrows as close as possible. And then I'm going to move the little paddle controller to the up position. It's going to meet up with the inside top of that. And once again, I'm going to move it back and forth to try to find the highest point. And when I'm there, just lay off the paddle controller that's pressing the probe to the top. And there we have our new diameter, 1.259, with a standing height of the centroid, or the center of the circle, at 6.53. All right, we're moving on now. This is a shadowgraph, also known as an optical comparator. I'm turning on the main power, and then there's switches on the left here for object light and the projector light. The projector light shines past the article through an optic, hits a mirror, and projects up onto the screen. Everything you see on that screen is upside down and backwards. I'm moving the Y control up and down and the X control side to side. So this platform, when it moves one way, it'll appear the other way on the screen. Alright. And don't mind me, I'm wearing a COVID mask here, and our quality lab is a little bit of a sweatshop for mask making at the moment. As I move left to right, we're seeing the X value in millimeters, and as I move up and down, we're showing the Y value in millimeters. Those little buttons to the right, we'll zero those out, or pretty nearly. They might be a little jittery. Here I'm showing it a little differently. I'm moving the table in the X direction. This is how you focus. This moves this optic in and out. We also have these object lights here. There's a little nut that will allow you to extend those out, position them wherever you want. If you want to get some detail on the face of that part near the optic, this is a good way to do that. And then you can just tighten those little nuts up and it'll hold. This vise, you can take your part in and out here. And it also has a nut on the left side here to move that whole vise piece in and out. So if you can't obtain focus through the optic, try moving the vise piece back and forth until you can pull a good focus. All right. So also on the screen portion here, you can see how this can rotate. And it has these little clips here, so if you have a transparent film that you want to lay on there with an outline of something, you can do that. That's a quick check for a small part. There is a grid pattern on this screen, a cross, and you can sort of make it out there. It is our index for making measurements. So what we're going to do typically is line something up on that cross and then move it up or down or side to side to obtain a measurement. Okay, so I'm going to move this over to the left. And what we're going to do is attempt to measure the height of one of those little slots. So I'm just kind of lining up the cross here with the slot, and I'm bringing it to the very bottom of one of those slots. It takes a minute here to get it lined up just so. And then we're going to zero out our Y, and then we're going to roll this up to the top of the slot so the line is just on the other side, and there's our measurement. So it is roughly a 1/2 millimeter in height. You can also select an inch scale for this, just the same. All right, so now let's take a look at, we've got this double circle over on the left side here. If we wanted to get the diameter of one of those circles, I would bring my center line to about the middle of that circle. And with the line just to the right side of that circle, I zeroed out X, and then I'm bringing it across so that it's just to the other side of that center line. And there we have it. We have about a 12.5 millimeter diameter across that circle. That's the basis of that. Let's say we're trying to get this angled side over here. It might be tough to mount in such a fashion that you can actually see it. There isn't a lot of travel in X for height, so you have to be a little bit creative on how you get this thing mounted. So here I'm trying it a couple of different ways, so I might be able to get it square enough to get a measurement. So there it is. It appears upside down because everything's backwards and upside down. And I've got it lined up on that center line, and I'm zeroing out X, bringing it across that feature to the other side. And there's our measurement, about 9 millimeters across, 8.8135. Okay, now we're going to look at a depth micrometer, yet another device here in our menagerie of interesting devices. Okay, this is what it looks like. It is a selection of push rods that you can use for it, for different heights. If you use a longer push rod, you may have to set it up on a gauge block in order to get a zero for that push rod, because this only travels about an inch maximum. So you could see we have the 1-inch push rod in there right now, and it's sticking out of that base portion. And ultimately what I'm going to want to do is zero that out onto our surface plate so that we have a good starting point. So let's bring it down. And this control actually has a clutch mechanism built into the handle here. The knob on the very end sets the clutch tension. And when that's right, I'll press the 0 button, and you can see our display is all zeroed out there. Okay, we've got our part here. And we're going to measure one of these holes. It is a blind hole that actually has a conical bottom on it, just like you see here in this drawing. And what we want to know is, what's the depth before that cone? Because if the push rod goes down through the center, it's going to go halfway down that cone. You're going to get an inaccuracy. So our push rod needs to be held tight against the side, and then we're going to make a couple of other measurements around. Get an average. So here we go. It's a little tricky because coming down the side you may sort of get some false hang-ups along the way. So I'm going to bring it down, and the clutch may spin it sometimes because I think I'm there. See, it feels like it's hard to turn here, but if I turn it out you can see it's only a tiny bit out, and well, the hole is deeper than that. So we're going to try again. We'll place it back down in there, turning it down into the hole some more. And it can't hurt to take a look at the print and see what this depth is supposed to be, so you have some kind of idea where you should be. And it says 0.15. Well, no, it's deeper than that. I believe it's about a 1/4 inch depth or so. There we go. We're bringing it down some more. And you know, if I do like the reading, I can use that lock lever that's down by my fingers to lock it into position so that you don't accidentally rotate this control while you're trying to remove it from the part. You can see we're getting closer to a 1/4 inch here now, and now it really feels like I'm hitting that shoulder. So there we have 25725, a little more believable. Try it here on the other side. I backed it down, bringing it down in there again. Two, 5. Hey, we're getting close. So this may require several tries in order to get it right. It's tricky to get those shoulders just so, but you're going to have to go around probably a few times, get an average. Well, thanks for watching this video. I hope it was insightful, and we'll teach you a little bit about how to use these.